Hi, I'm Chris Brown, and this is section 1.13 in a grad course at WPI on axiomatic design and manufacturing processes. The course, this is going to concentrate on the archival technical literature and does not address axiomatic design in this case specifically, or manufacturing processes specifically. But this is important, and it's important to understand in a grad class. So the technical and scientific archival peer-reviewed literature. This is the primary way that we disseminate new knowledge. Now, WPI, like many other higher education or institutions for higher education, has as its mission the creation and dissemination of new knowledge. So the dissemination is done primarily through peer-reviewed articles in the scientific and technical literature. So we're going to take a look and see what these are. These are done at relatively high cost. Often a grant will be some tens to hundreds of thousands of dollars and will produce perhaps one or several papers. The papers, though, are sort of the academic, if we would like to say, tinder. This is what is used to measure sometimes success in academia. They also have high value. If one of these papers has addressed something that you need to know, then if you can find that paper and you can extract the information that you need from it, then you have saved yourself a lot of money. Now, we used to say before we had all of the electronic ways of searching the literature that several years in the laboratory will save you several minutes in the library. But now you don't even have to leave your desk to search the archival literature. So there are projects that I have worked on where I've been able to advance them months or even years by finding the information that we need in the archival technical literature as opposed to developing it ourselves. So these are research papers, and what typically do they look like? They all have a similar kind of anatomy. So we'll start off simply. There's a title. There's good information on the title, and we'll talk about that more later. Authors and their affiliations. And certain authors are going to have certain themes that they work on, and certain places may have better facilities than others, so this is also interesting. The abstract, though, should tell a good story about what the paper's about. Following the abstract, we get into the bulk of the paper, and there's an introduction. There are generally 4 things that are covered in the introduction, not necessarily in this order: objective, rationale, state-of-the-art, and approach. So the objective is where you describe essentially, often in a sentence, and sometimes just a few, or a short paragraph, what the paper's about. I like to lead with the objective in my papers, but many people put it at the end of the introduction, and they may start off with a rationale. And so the objective says what you're going to do. The rationale says why that's important. The state-of-the-art tells you what other people have done or what other researchers have done, so that should be full of citations. And the approach essentially compares and contrasts what you are planning on doing with what has already been done and appears in the literature. Methods. So this should be a description of what you're doing that is good and clear enough so that somebody else can repeat what you have done, somebody with knowledge in the field. So you can think about who your audience is in these things. So it should be somebody who is skilled in the field. Results. So here's what comes from the methods. When you apply the methods, you make these observations, and here are the results. Then discussion of the results. And this may be to compare the results with what other people have gotten, to look at them critically, to look at the impact of maybe different methods on what the results would be like. And then the conclusions. A simple list of the findings. What have you found? What new knowledge is there? Summarize succinctly in the conclusions. Some people write a kind of summary of the paper, but that's what the abstract is for. I would rather see even a numbered list of here's the takeaways, here's what you can take to the bank from this, as opposed to a recap, which really belongs in the abstract. And then the list of references, and this can be terribly important. If you know a field well, you can often tell what's going on just by, in a paper, what perspective it's taking just by looking at the references. How do we read a technical article? Well, we don't read it like a novel. In technical articles, I jump around. A novel wants to develop a plot or a story. We don't want to jump to the end and spoil the ending. But when I'm reading a technical article, I need to get some value out of it. So I'm starting with some questions in mind that I need to answer in order to advance my design solution. So as an engineer, our number one job is to do design. So when we go to look at a technical article, we're trying to find out what is it in that article that is going to help us with a design solution. Now, there are some papers that we write that are just sort of background. Actually, I try to avoid those, but sometimes you're just doing a background section. That's not what we're talking about here. We're not looking for information for background. We're looking for solid information that can be used, essentially, to relate FRs and DPs or PVs and DPs so that we can advance the work on our design. We can see if there's coupling. We can understand what is the best DP to use to fulfill an FR, or what is the best way to make a component, what's the best PV to choose. And what we want to do too, since time is important, advancing design and getting designs out is important, we want to see how quickly we can find out what it is we need from this paper. Is it in the paper indeed? Is this the right paper to be looking at? So we need to extract what we need, and how do we do that? Well, first we look at the title. And often we can disqualify a paper because the title is too remote from what we're doing. The next thing we'll look at is the abstract. Now, the author, in about 5 or 6 sentences, should describe what's valuable in that paper in the abstract. Actually, they should cover a little bit about what's in the introduction, methods, results, discussion, conclusion, all in the abstract. So we should see the highlights there. So if the title is good and the abstract still looks promising, then the next thing I do is I jump to the end and I look at the conclusions. Sometimes it's frustrating because people might have some interesting results and just not have written good conclusions and have a kind of wandering summary. So sometimes I am charitable about retaining interest in the article if the conclusions don't seem to be well written. But generally I'm looking for some indication in the conclusions that the information that I need is actually here. And I may find the information right in the conclusions. Now, then the next thing I'm going to do is say, well, sort of what hard observations do they base these conclusions on? So let's go look at the results. And in the results there should be graphs and pictures and tables that are going to help us understand how those conclusions were reached. And sometimes this is all you need to do. Generally I'll skim the rest of the paper if I'm going to use it. If the paper really looks good at this point, though, I often want to make sure I look at the state of the art, because that could be useful in my state of the art. And they may have found some references that I have missed. So, but here's generally what you do. Title, abstract, conclusion, results. And if by that time you don't think the paper's interesting, it probably is not interesting. Let's take a look at what a peer review is. So an author, a researcher, submits a paper to a research type journal, a peer-reviewed journal. Now the journal has an editor, and they send it out to other engineers or scientists, usually at least 3, to read and comment. So the paper might be rejected. In fact, the editor can give it what's called a desk reject. Just look at it and say, no, I'm not sending this out. I'm not going to bother my reviewers with this paper. Maybe because it doesn't fit well in the journal, or maybe because the quality just doesn't look good. But the paper might be rejected or sent back to the author for revision. Now, the editor can also override this, and this happened, there are some instances of this that editors have related to me with landmark papers, where the reviewers were not supportive, but the editor felt it was important enough to publish. So the editor can take some risk on themselves sometimes. So here's an example. Anyway, so it can be revised and then published, and so there are some disadvantages to the peer review system in that it tends to advance the kinds of things that the reviewers are working on. Reviewers tend to be much more favorable towards a paper if they are cited in the paper. So there is a kind of intellectual inertia that the peer review process fosters, and it tends to be conservative with respect to innovation. But it's hard to think of a better process, a better way of taking a look at, all right, is this paper going to be good? And if we find a paper published in a peer-reviewed journal, generally it's good. Now, here's an example of a trade journal. So it's not peer-reviewed, and I want to make a distinction here. So this is something from the super abrasive industry, and it's got lots of advertising, and it's talking about the upcoming International Machine Tool Show in Chicago, and so it's good. It's got interesting information, and if you're in the industry, you probably want to be looking at these things. But for the point of view of this course, this is not what we're looking for citations. We also have sort of societal magazines. So here is, and actually you can download these different ways now. So here is the Society of Manufacturing Engineers Manufacturing Engineering magazine. This also is not peer-reviewed. Sometimes there can be very good articles and they can have very useful information, but this is not peer-reviewed, and it's not really written at a graduate level. It's written more at an undergraduate level. But as I said, it can be useful, but it's not what we're looking for in this course. If you couldn't find anything else, you may give some citation to these. But this is the kind of journal we're looking for. So this one is scanning, and we've published things in here on surface metrology, so this tends to be more useful for us in looking at surfaces, and this happens to be an issue that I was involved with, but this is peer-reviewed. Here's some that will be more useful in this class, perhaps, and this CIRP is the International College for Production Engineering, and so they have their own engineering journal of Manufacturing Science and Technology, as well as their annals, which are papers, a collection of papers that were presented at their annual meeting every year. So there's a lot of good stuff in the CIRP, and there's a connection to their website. The Journal of Manufacturing Processes is a research journal associated with the Society of Manufacturing Engineers. And the ASME, the American Society of Mechanical Engineers, also has a journal on manufacturing science and engineering, and here's a link to that. So there's some examples of archival journals that address manufacturing that will be useful in this class. As you get involved in that process, and as graduate students you may be writing and submitting articles, and you'll probably get some rejected. And when I get some rejected, I like to think of Goddard, who, of course, made the first liquid fuel rockets, and is a WPI grad. And we see him here south of Worcester with his first liquid fuel rocket. Now, this was not actually a rejection from a journal. This is taken from the New York Times. But they were pretty tough on him. Does not know the relation of action and reaction. and the need to have something better than a vacuum to push against. And he seems to lack the knowledge ladled out daily in high school. So they're pretty tough on it. Some 40 years later, when men walked on the moon, they published a retraction. And there you can read more about it in Wikipedia. All right, so this concludes this section on peer-reviewed journals. This will be useful in selecting peer-reviewed journals for your homework assignments.